Okay, welcome everyone. Welcome to this second talk on the Paleobiodiversity and Evolution Symposium. I am more than happy to introduce Dr. Juan Carrillo. He's a postdoc at the National History Museum of Paris, France. And thank you very much, Dr. Carrillo, for joining us. He will be taking questions in Spanish and English, so feel free to post your questions on the chat, and the stage is yours, Dr. Carrillo. Thank you very much.
Thank you. Okay, I will just share my screen. Okay. Thank you. I'm very happy to be in this virtual meeting and be part of this event. Okay. So if you open a textbook of mammal evolution, you will find that American mammals, and in particular South American mammals, have a unique evolutionary history because South America was isolated during most of the Cenozoic, which is the time period that covers the last 65 million years, shown in this timetable. Since the end of the Eocene, around 50 million years ago, when South America separated to the Antarctica, until the late Neogene, when the Isthmus of Panama connected the continent with North America, South America was isolated from other continents. And there was several lineages, endemic lineages of mammals that originate and evolve in relative isolation during this time. This is included several groups or clades of native ungulates, herbivore ungulates. Also, the Xenartrons, which have some of the living representatives today, like sloths and armadillos, but also included a high diversity of species in the past, including the ground sloth and the coniglyptodons. And by the end of the Eocene, we had the arrival of two groups which today constitute important components of the South American fauna, which are the caviomorph rodents, the guinea pigs and the capybaras, and the platyrrhine monkeys. And these groups diversified during most of the Cenozoic in relative isolation until the Isthmus of Panama connected the two continents and facilitated the exchange of fauna between North and South America in what is known as the Great American Biotic Interchange. And this can be regarded as a natural history experiment when you had two continental faunas separated for very long time, geologic time, that were connected by a narrow bridge of about 60 kilometers wide. So you had the South American endemic mammals, such as the ground sloths, the glyptodons, the rodents, and so on that could move north. And from North America, you had the placental carnivores, the ungulates, proboscideans that could move south. And paleontologists recognize that the interchange was relatively balanced at first, meaning that there were a similar number of immigrants moving from one continent to another in both directions. But then in the Pleistocene, there was a result of an asymmetric pattern in the end result of the interchange. In particular, in South America, there was a higher proportion of immigrants that arrived from North America than vice versa. So we wanted to investigate further what was the mechanisms that led to this asymmetric pattern in the biotic interchange. And because diversity ultimately depends on origination, extinction, and dispersal, we can present or test it 4 different hypotheses, not mutually exclusive hypotheses that could lead to this asymmetric pattern. The first one is that the asymmetry could be the result of a higher dispersal rate from North America to South America, which is here in the panel A illustrated. A second option is that the dispersal rates was similar between the two continents, but the immigrants from North America, once they established in South America, diversified more, leading to an asymmetry. Or it could be also that the rate of dispersal was similar between the two continents, but the South American mammals went extinct in a higher extent than the North American mammals. Or it could be that the rate of dispersal was similar, but the total, let's say, taxonomic richness or species richness in North America was higher, and therefore there was a total number of immigrants that was higher from north to south and south to north. And as I said, these are not mutually exclusive, but this is because a combination of them could also resolve the asymmetry. So to test this, we use fossil data. We compile fossil occurrences from the two continents, from the paleobiology database, to which our group has also contributed. And this data represents fossil occurrences with information about the age and the geographic distribution. And we use it to estimate origination, extinction, and dispersal rates during the biotic interchange. And we use Bayesian approaches to do this. Importantly, these approaches take into account differences in sampling and preservation rates in the fossils as they are estimated from the data. So this is the sampling rate shown from the two continents, and you can see that the sampling rate is higher in North America. Overall, through time, the rates represent the estimated number of occurrences, fossil occurrences per lineage per million years. So the origination, extinction, and dispersal rates that we estimate take into account this factor. So here I'm showing you the total diversity or the diversity through time of immigrants and natives in the two continents, from the early Miocene to the Pleistocene. And in solid lines is the total diversity in each continent. In the dashed lines is the diversity of the native taxa. And in the dot line is the diversity of the immigrant taxa. And I should say that we classified clades as being native or immigrants based on the oldest occurrence of the fossil record. So for example, the crown sloths belong to the Thenardians, and the oldest records on Thenardians are in South America. Therefore, the Thenardians are a native group in South America and an immigrant group in North America, and so on. So you can see that overall the diversity tends to be higher in North America, with the exception of the late Miocene. And then in South America, you will see that there is a decrease in the diversity, especially in the diversity of native mammals from the late Miocene to the Pliocene, and this continues towards the Pleistocene. And this decrease in diversity is not so strong in North America. And then when you see on the immigrants, you will see that the diversity of immigrants during the interchange in the late Miocene was relatively similar. It was low as it was starting, and then increasing in the Pliocene. But then in the Pleistocene, we see that in South America, the number of immigrants increases considerably to the point that it was almost similar to the diversity of native mammals. And in contrast, in North America, we see that the diversity of immigrants did not reach such a high level, and it was considerably lower than the native mammals. And this is what we call the asymmetric pattern of the interchange. Okay, so when we look at the diversification, the net diversification is the origination minus extinction rates of the immigrants. We found that there were no differences in the rates of origination of immigrant taxa in either continent. They had overall both continents, the immigrants had high origination and low extinction rates. But when we look at the diversification, again, net diversification, again, the origination minus extinction rate, we found that the native mammals of of South America had a higher, relatively higher extinction during the Pliocene. And this is related in the diversity with this decrease in diversity from late Miocene to Pliocene. So there was a disproportionately higher extinction of native mammals in South America during this time period. Then when we look at dispersal rates, we found that there were not significant differences between the dispersal rates in either direction. Dispersal rates were low in the late Miocene and increasing in the Pliocene, and the highest in the Pleistocene. And dispersal event understood as a range expansion of a taxon from one continent to the other. And these rates then correspond to the expected number of dispersal per lineage per million years. So altogether, our results show that the asymmetry in the biotic interchange was not the result of a higher dispersal rate from north to south. Neither was the result of a higher origination rate of immigrants from North America once they established in South America, but it was caused because there was a higher extinction of native mammals, native South American mammals in South America, and this reduced the pool of taxa, the native taxa that could migrate towards the north. And it was particularly important because in the following time period, in the Pleistocene, is where more dispersal events took place. So there was already a reduced diversity number of native taxa in South America at that time period. So although the rate of dispersal was similar, there were less native, relatively less native South American mammals that could migrate towards the north. Now, when you look more closely, the fossil data, the available, what is known from the fossil data in the continents, you will quickly notice that most of the occurrences, and for different reasons, most of the data come from higher latitudes, namely temperate regions. And this is true for all the time periods, including the Pliocene, when we observe these higher extinction events. In particular, in South America, there is a rich fossil records in the region of the Pampas, and the studies from these regions, previous studies have shown that there was an extinction, a higher extinction during the Pliocene in the region. So we think that this is the higher extinction of native South American mammals occur in the southern part of the continent. Now, it's not totally clear what could have caused the higher extinction in the southern part of South America. But it is known that towards this time period, towards this time, the climate was becoming drier in southern South America and cooler, and this could have affected the native fauna. Also, although there were still not that many immigrants, there were still arriving quite a few, but there were already some arrivals of predators, placental predators, placental mammals, carnivores that arrived in South America. And there are some studies that suggested that they could be perhaps more effective predators and could have contributed to the extinction of some native mammals in South America. There is also a report and evidence of impact of asteroids in this region, although testing for the causal factor that how this could have affected the extinction is more complicated, but at least there is some temporal and geographic correlations with some impact events. And another idea that has not been very much explored is that we know that from studies in invasive biology is that invasive mammals can bring new parasites and diseases to the native populations of mammals, and they could affect it to a considerable extent. So maybe the immigrants that had arrived at that time brought some parasites or diseases, and they maybe could contribute to this extinction of native mammals in South America. But then if this was in the temperate regions, in the southern part of the continent, what happened in the tropics? So historically, the tropical fossil record in the continent has been underrepresented, but there is a growing record of fossils. And I'll show you today what we have learned from studies in Northern South America, in particular, northwestern Venezuela and northern Colombia. And this characterizes South American faunas from in the tropical regions before and during the biotic interchange. So before the interchange or the arrival of immigrant mammals, it was a characteristic South American fauna. But during the Pliocene and Pleistocene, we already record the arrival of several immigrants from North America, in particular members of the raccoon family, the Procyonids, and members of the camelids, of the llamas family, the camelids. But overall, there is a high predominance of South American mammals in this fauna. And this is possibly because contemporaneous faunas in the southern part of the continent had a higher diversity of immigrants that arrived from North America, even though they're thousands of kilometers farther away from the land bridge. And recent studies from these tropical faunas show that this is not really a factor of sampling, because now we have a very good idea of the mammal diversity in these localities, and in particular the same stratigraphic level, and still the pattern is the same. There is a high predominance of South American mammals. So this highlights that there were important biogeographic differences that had to be taken into account if we want to fully understand this biotic interchange. So in summary, our study shows that the asymmetric pattern of biotic interchange is the result of a higher extinction of South American mammals, native South American mammals in South America. And this higher extinction likely occurred in the southern part of the continent. And in what is known from the tropical fossil record highlights important biogeographic differences that need to be taken into account to fully understand this important biotic event. So with that, I would like to acknowledge to the funding agencies and different institutions that have supported this work throughout the years, and of course, all the collaborators. And thank you very much.
Thank you so much, Juan. Para mí, wonderful talk, a lot of beautiful illustrations. I really enjoyed. Very interesting topic. There are some questions. There's one first question in Spanish. I will read it in Spanish. Es de Lucia Fernández Goya. Ella dijo que tú ya respondió la pregunta en la charla, pero puede ser que sea interesante adentrar un poco en este tema. ¿Se sabe por qué hubo una mayor extinción en América del Sur con respecto a América del Norte durante el Plioceno? Si puedes hablar un poquito más de eso.
Sí, exacto. Bueno, pues como dices, el tema no sabemos exactamente. Proponemos unas hipótesis que están principalmente basadas en hipótesis que han propuesto otros autores. También han publicado otros autores. Como dije, era un tiempo importante de cambio climático y ambiental, más seco, más frío en el sur del continente. Tal vez algunos de los predadores que llegaron placentados pudieron contribuir a esto. Está el tema de los impactos de los meteoritos. Recientemente salió un trabajo en Scientific Reports de Prevosti y colegas. Ahí pueden ver, hacen un estudio muy detallado de toda esta región. Pues una hipótesis que me parece muy interesante, pero no he visto ningún estudio que lo haya evaluado, es qué tal vez pudieron ser un tema de parásitos o de enfermedades que llegaron estos inmigrantes que están llegando al principio, pero la verdad no sabemos aún. Es el próximo paso.
Perfecto. Hay una más ahora en inglés. It's a question from Neander Hemming. I think I pronounced correctly. Hi, congrats for your presentation. I'd like to know if North American immigrants could be superior competitors, replacing South American species of the same functional groups, causing extinctions.
Yeah, so this was originally like thought that there were native South American mammals were outcompeted by North American ones. However, most recent studies that have looked at this, they have not found that this is necessarily the case. In particular, this is the case of the placental carnivores and the predators, but it seems that many of the metatherians or the native South American predators were starting to go extinct before the arrival of ecological equivalents from North America. So there is not. Of course, there's always the possibility that we found a fossil record that makes us reevaluate the timing of arrival of some groups. But for the moment, it seems that by the time that these placental carnivores arrived, the metatherians predators were already on decline, and the same seems to be with other groups like of native mammals. So our study, what this suggests is like, for some reason which is still not very clear, the South American native mammals were already on decline by the time that many of these North American mammals start to arrive, and then it seems it's more like they took advantage of an ecological opportunity and they diversified. Yeah.
Great, perfect. Another question from Luan Mota. It's in English. Juan, great talk. How could we explain a higher proportion of migrants in the southern part of South America when compared to the northern part? I would expect at first to see the contrary. The closer to the connection, the higher the immigrants proportion.
Yes, that is counterintuitive, I will say. At first, that was also what I thought. Like and the thing is, most of what we know historically because of most of the fossil records comes from the southern part of the continent. So that's the pictures we had always when we look at we talk about this biotic interchange. But as this highlights the importance of doing conducting paleontological research in the tropics, because as we are recovering more data, we start to see that we cannot simply extrapolate. And perhaps one of the reasons is that, like South America has had a tropical forest for a long time. You could expect that several of these native mammals have really evolved for a long time during this in this environment, and at least for some clades of North American mammals, they were not really that able to establish in this environment, but then the question is how they made it to the south of the continent, right? If they were not so good in the tropical forest. One possibility is that they could have used the Andes. There's some paleontologists have proposed this as a corridor of dispersal that could be more similar to a temperature environment towards the south. And yeah, of course, this is what we see from the fossil record. There are some groups that clearly have arrive from South America and radiate in tropical forests. Like for instance, the rodents, the North American rodents, but they perhaps are not the best represented in the tropical fossil record. So that could be, but overall we see that I think perhaps it's more like a biogeographic effect, or we could think of biome restrictions that they could not establish for some reason in the tropical forest, but it's counterintuitive. I agree to a certain extent. Yeah.
So I have more questions. I have two more including. Also, I have some of my own, but I think we are reaching the final of the session. I will thank you very much, Dr. Juan. Amazing talk, very exciting. I think the number of questions stressed that out. How exciting was it? And I will ask the people that are posting the questions here to either contact Dr. Juan by email or Discord. I think you are in Discord server, right?
I don't know what is Discord. In the poster thing.
Yeah, it's the.
Yes.
I think I saw your name there. So yeah.
Yes. I just didn't remember the name. I joined. I was checking the poster earlier. So yeah, you can contact me there or just in the email in our publications. You can look at and contact me. Yeah.
Thank you very much, Juan, for your participation. It's very important for our event. You're being here, so thank you very much.
Thanks a lot for the invitation.